So that's the end of 16. So let's read 17. Also located on the X chromosome of this same cat is a gene that codes for deafness. So I think I've told you this before, that most of the time, you don't have a gene that actually codes for when you go through transcription, translation, and you end up with a protein. There's not a protein that makes you deaf. There's usually a not functional protein that in some pathway involved with hearing, that particular protein, if it doesn't work, it interrupts that pathway and it leads to deafness. So most recessive genes are just broken. They're just broken. So this is broken, it's recessive, and if you get the broken gene, you make the broken protein, which means you have the broken pathway. So they say a black female cat that is heterozygous for deafness. Okay, so let's just start over here and put what we've got. So you've got a black female. So that's the only way that you would be able to be black, because it's codominant. So we learned that back over here. So we wrote right here, black female. And she's heterozygous for deafness. So I'm going to go ahead and write these like they're separate, but we'll combine them here in just a minute. So this is what they just said here was the heterozygous for deafness. Is crossed with a yellow male. So we've got a yellow male right here. That is not deaf. So for the female, because we've got different, these are heterozygous, you're going to have more than one possibility for gametes from this female. So we'll do the whole over, and we'll do under, but because both of these are big B's, they'll be the same. So when we do that, we've got an X that could have the combination of both dominant for color and for the gene for deafness. And then if you go under, so over is what I should have said, you could have the big B with the deafness recessive allele. So that's your options there. And then for the male, on his X, those two come just the way they are because they don't have anything for us to partner them with. So yellow for pigment, working gene, and then the Y. So we'll do this cross and it'll look just like this one, except instead of having one thing, we'll have two. So put the male on the top. Y just goes by itself. And then break apart these two options as far as you'd have a chromosome that would have these two together on it, or you could give this chromosome that would have these two together on it. So then we'll figure out what we will be able to have for possible offspring. So we'll make a female here, and the female would have, for color, we'll put those together. And then for hearing, we'll put those together. And we're only doing this just to make it simple. We're really just looking at the two of these together. And then we'll do the same thing here. The only difference is that you'll still have a calico female, but this female is going to be heterozygous for hearing. So in this case, you'll have a male that's black and can hear. And then over here you'll have a male that's black and cannot hear. So when we write these, we'll write them out. What are your options? So both of your females are going to be calico and can hear. So you'd have, of these options, you'd have 2 of the 4 would be a female that is black pigment that can hear. Because it doesn't really matter if you're homozygous dominant or heterozygous, this dominant allele creates a functional protein that allows the pathway to work. And then a 4th of your options will be a black male that can hear. And then a 4th of the options would be a black male that's deaf. So if you break that out, you would have all black cats. And then you'd have 1/4 are deaf. And that would have to be the males. So that answers 17. So it said, hint, place 2 letters on the X chromosome in your cross, which is what we did. You can do it. I'll show you another way. This is a way that I've done it before. So I've written these all out separately, just like we did. And then I did the combinations, but I just looked at color and just looked at hearing, and then it shows these. And you can, by math, you can have all females are calico. Wait, what did I say? Did I say all black cats? All black cats male. And then all calico cats for female. I'm glad I looked at that. Wow. So it lets you just walk through here and do them separately. You can do the math. But mostly what they want is they want you to be able to describe the situation as far as the only ones that are deaf are males. And the males are black, the females are calico. So, okay, 18. In mice, spinning behavior is caused by a dominant gene that affects the mouse's equilibrium. This gene is lethal if 2 alleles are present. So, if you have dominant, this is lethal. 2 spinning mice are mated together. So, why put D's? Let's put S's for spinning. So, that's lethal. Heterozygous would be a spinning mouse. And then homozygous recessive would be non-spinning, which is normal. So 2 spinning mice are mated together. Well, they definitely can't be this because they would never form. If this became the embryo, then it would just arrest in its development. I'm sorry. So I would have a spinner crossed with a spinner. And it said, show the cross. What are the phenotypes of the offspring and in what proportion? Be sure to eliminate any offspring that do not survive. So let's just finish this cross real quick and then we'll do what they're saying. So what they're saying is this. Instead of being there's 4 options and you'll say 2 of the 4 or 1 of the 4, there's not 4. There's 3. So you're going to eliminate this one because it's lethal. And now everything's in thirds. So you'd have 2/3 of the mice would be spinners. and 1/3 would be normal. So that's what they're working with there, trying to get you to get rid of that. Then you've got questions. I'm going to just show you what you could do that you don't need me. So this is a blood type question. So you can do that where they'll tell you what these are and they'll have you eliminate to see who belongs to who. And these tables, like this Holly is B, these tables are just broken. Then a child has type A blood. What are all the possible blood types of its parents? That's a little tiny question to be an awful lot of work. So I'm going to have you skip this one. And then the chicken question is very difficult. We'll come back to it. These I would like for you to do. So don't use Punnett squares. Do math. So you're going to do the A's crossed with the A's. And then you'll do the B's with the B's. And instead of stopping there this time, just because it's math, you can keep going, the C's and the D's. And so you'll have a lot of like 4 fractions that are going to be multiplied. So you're going to use the math option. And then this question is the same type of question that we've had before when you look at how many unique gametes can be produced. So this is always going to be the number of heterozygous pairs. So it's 2 to the n, and the n is the number of your heterozygous pairs. Okay, so you can finish all of those. So that'll be the end for today. And then tomorrow we'll continue our questions. We'll come back here and take notes. And then we're going to start doing the primary kind of questions that are part of this chapter, which are linkage questions. All right, I'll be in a Zoom in case you need me, but otherwise this is what's expected to be completed. So you would be completely through with what I've asked you to do here, knowing that we said we were going to skip 20 and 21. I'll walk you through my notes for those and where I've worked them out, but not today. You'll finish all of this, and then you need to be sure, I would like to go back here real quick, make sure you have everything turned in that's due. Let me just get my grade book. See if that's on there. Nope, it's in here. Okay, so you had foldable genetics practice problems. So those trying to find them. They looked like this. Okay, they said practice genetics problems. If you didn't turn that in, you need to do that. You're going to get a 0, and it's worth 17 points, so don't do that. Then we had the Beyond Pea plants, and that's the one where we were just tearing the pages off. And you turned in page 1, 2, 3, 4, 5. So the first 5 pages.